My name is Aurora González Vidal. I am a postdoctoral researcher at the University of Murcia, and I have won the first Frances Allen Prize with my thesis, Data Analytics for IoT-based Smart Environments. In the presentation, I will provide a quick overview of my work. I will start by an introduction that provides context and motivates the work. Then I have summed up the original objectives to 3, so I will mention them and relate them to the publications that include the results to support them. Then I will show some of the successful research lines that my thesis have led to, and I am developing as a postdoc. The thesis was based on a compendium of articles, and it was developed under the context of an FPI grant. In the 4 years' time, I contributed to 2 H2020 European projects, Entropy and IoT Crawler, and 2 national ones, Edison and Perseides. I also realized 2 internships, one to the UK and one to Australia. Thanks to the proliferation of interconnected IoT devices, huge amounts of data are being gathered nowadays. However, what makes an environment smart is not the sensors, but the ability to process and learn from all the data that they provide through its analysis, in order to provide services that are new or that are improved. In short, the aim of my thesis is to explore, analyze, and implement ways to benefit from the IoT paradigm by means of applying AI. The services that will be provided from my work are motivated to fight climate change in a broad way, since information and communication technologies have the potential to reduce 20% of global CO2 emissions by 2030. In that sense, the first objective focuses on creating AI-based methodologies to be applied in smart cities for predictive modeling and energy consumption and pattern extraction of heating, ventilating, and air conditioning usage using real data. When using real data, several challenges arise. IoT data exceeds the capabilities of traditional database engines due to their velocity, variety, volume, and other V's that characterize the big data paradigm. The second objective is to detect and address some of the challenges by means of big data processing, such as the reduction of data and the reduction of characteristics. In order to implement complex AI-based solutions, we need to govern our data through architectures that can serve for the purpose of the whole process: data collection, data quality, data storage, data processing, data analysis, and service provision. This was the third objective. We created architectures for smart cities and personalized energy efficiency services. With regards to the first objective, we managed to fuse information relating weather, consumption, occupation, and HVAC usage to create methodologies for forecasting energy consumption with different horizons, hourly, daily, weekly, etc. And we also created higher-level entities by grouping HVAC users according to their profiles. Here are the publications in which these results are published. As an example, meteorological data was gathered from 2 different sources. We performed correlation analysis and principal components in order to extract some insights from the relationship of the variables with energy consumption. As you can see, the temperature and the radiation correlate greater with energy consumption than others. We tried many algorithms, including random forests, artificial neural networks, and we did cross-validation for hyperparameter tuning. As you can see here, we reported the root mean square error and its coefficient of variation, but we also provided more metrics for comparison in the works. Between the habits that occupants can change to reduce energy usage, we find the adjustment of thermostat set points. We monitored HVAC devices and aggregated their data to obtain the daily interactions of the users with them, to turn it on and off, to change the set point, the hours of operation, etc. We performed clustering analysis of them, and one of the most explainable results divided the users in 2. One that interacts with the controller often and consumes less, and another group that tends not to interact with the set point but are higher consumers. This serves for the future creation of recommendations. Now, for the objective of big data processing, we presented an algorithm named BEATS that aggregates and represents large volumes of data, creating sequences of lower length. And we also developed a feature selection methodology for multivariate time series forecasting. BEATS was based on segmenting a time series in blocks, then transform this block into a matrix, send it to the frequency domain using discrete cosine transformation, and then the final eigenvalues would represent this block. As you can understand, we would have a long series that is reduced or constrained. I'm showing here the results when combining bits with classification mechanisms. We can see that it reduces greatly the processing time while maintaining or even improving the classification results in some experiments and with some datasets in comparison with algorithms that are the state of the art. Continuing with the aim to ease the analysis performance, we also study feature selection. A feature selection method is a search strategy where the performance of several feature subsets is measured with a given evaluator, and it serves to reduce the input shape. We try wrapper, filters, univariate, multivariate methods, and we used multi-objective evolutionary search, MOES, that has two objectives: maximize performance and minimize cardinality. And maximize performance means also minimize the error. We tried several strategies and found the best one for the purpose of energy consumption, including the importance of the inputs. But this was a general methodology that can be applied to any multivariate time series predictive problem. Then, with regards to the deployment of architectures, we created one that had 4 layers: technologies, fusion, management, and services, and we use it to create recommendation with regards to energy for building users. The proposed platform fills the gaps that others had, such as that there is no other platform that focuses on the energy domain, that they do not include the analysis within them. They use external software. They normally choose between survey of monitor data, but not both. And also the feedback is not adaptive. The platform and the results do not adapt to the feedback of the users. Our proposed platform is composed of several layers. The IoT and communication layer connects the sensors to the platform. The data modeling and fusion layer homogenize the data. Then the algorithm design provides support for data mining and recommendation rules creation. And finally, the service layer connects the platform and the users. We have a dashboard, an app, and a serious game through which the user received recommendation and educational tips. These services were used in 3 different pilots within the Entropy project, and we managed to save between 15 and 25% of energy in several campaigns. Here you can see some references to almost all the work from my PhD. Then, as a postdoc, I have developed further some of the research, including the following points. I have created a transfer learning strategy to share knowledge between buildings. My project was awarded in the first NGI Explorers Call, and I did a 3-month internship in the USA for developing it. Then I extended the context for the application of the thesis developments. I'm currently a postdoctoral fellow of the Fundación Seneca through a European project about smart agriculture called the METER. For the transference of knowledge to the industry, I am working with intelligent logistics through the project we call TRACKS, that was selected by the IOSC Digital Innovation Hub in a call for business pilots. And I also did a short internship in the startup Matereo for applying AI in the field of preventive maintenance in bridges. Finally, I am also collaborating in other 2 European projects, WaterMed for improving irrigation and water resources in agriculture, and Phoenix for improving the smartness of buildings through hardware related to energy. Thank you very much for your attention, and please do not hesitate to contact me if you have any question or suggestion.